Hello everyone, welcome back to another video. My name is Jamil, and today I'm here to help you guys through another lead code. Today's question was a little tricky for myself, so it took me a little bit outside of the video to solve and actually try to understand what the question is. So if I end up taking an extra moment to try and explain what the question is, please bear with me. It is a little bit complicated. But there is a trick to it. I did end up using the hints for this problem, and I will go over them in detail with you guys just because I think this question might need it. If you do end up coming up across this question in an interview, I think it will be your best move to ask as many questions as possible, and to try and write down as much information as possible so that it ends up making sense to you. All right, so without any further ado, today's question is titled minimum number of moves to seat everyone. All right, and it is an easy question. It has a high acceptance rate and a good like to dislike ratio. But let's see here. There are n seats and n students in a room. Okay, you are given an array seats of length n, where seat I is the position of the ith seat. And you're also given the array students of length n, so they're both the same length. Keep that in mind, okay? Where students j is the position of the jth student. So what does that mean? This was a lot because this is a confusing sentence. Essentially, what they're telling us is that in our problem, in our function, we are going to be passed two parameters. They are both going to be arrays of numbers. The numbers represent placements of students. Okay, so you can almost like think of like a seating arrangement and where they are currently placed, and then where do you want to place them after the seating arrangement has been performed. Okay, let's carry on with the question, and then I'll go into it a little bit more in detail when I explain to you this first sentence in the example. But you may perform the following move on any number of times, okay? So you can increase or decrease the position of the ith student by 1, i.e. moving the ith student from position x to position x plus 1. Let me just make this a little clearer, okay? From position x to position x plus 1 or x minus 1. So like if they are in position number 2 and they need to move to position number 3, that is one direction, right? That is one move. And please do take note that the direction does not matter. It is still a move. It is counted as a move that we need to do, okay? So we need to return the minimum number of moves required to move each student to a seat such that no two students are in the same seat, okay? So we need to make sure that the seating arrangement works. Note that there may be multiple seats or students in the same position at the beginning. All right. So, kind of complicated. Let's see what it's trying to say. So like I mentioned earlier, we are being passed two arrays, right? So the first one is titled seats, and it tells us in this sentence right here, you're given an array seats of length n, where seats I, so let's say you are, remember, we are dealing with arrays here, so I starts at 0, like your first index of an array starts at 0. So seats of 0 is 3, right? Because this is what that indicates, right? If you were to bring seats of 0, like console log seats 0, right? And let's just return 1 for the time being. You will notice that it returns 3, right? So when we are looking at the number 3, the number 3 indicates that it is the position of the third seat. All right. So this represents the first student. The first student has a position of 2. All right. So the first student is moved from position 2 to position 1 using one move. No, sorry. I have to fix that. But it refers to the third student of position 4, right? So the third student is moved from position 4 to position 3 using one move. All right. Now, seats of 1 will give me the number 1. It is talking about, right? So seats of 1 gives me 1. So that means it is telling me about the student in the first position, right? So the first student is moved from position 2 to position 1 using one move. So second student, it tells you here it is in position 2. You need to subtract 1 so that it matches with the seat assignment of position 1. You can see how it gets a little bit complicated, right? And then when you are doing seats of 2, right, gives you the number 5. The number 5, I mean, we don't really have, the second student is now moved from position 7 to position 5 using 2 moves, because, you know, the fifth student, we don't have the fifth student, but what happens is that we have one remaining student and one remaining seat, and we just assign them to those seats, okay? It does get a little bit complicated, so how do we go about, like, doing this? Because now you have to try and see, like, you know, you are taking the index of the seats array and trying to find where, what index, like what number it represents, that then matches the student with an assigned seating, right? If we take a look at our hints here, already was on hint 3 of 3, but there are ways that we can think about this problem, okay? So can we sort arrays to solve the problem? We can see, like, if we took a look at the way that the question is laid out, you'll notice one thing, that if you are dealing with the seat positioning, you want, like, you can assign seats 1 to then assign seat 2, then assign seat 3, 4, 5, 6, 7, and so on and so forth, right? So you can sort your arrays so that you can work in, like, an ascending order of seats. But since each seat represents, like, its corresponding student, right? If you are talking about seat number 1, right, then you're talking about student that sits in seat number 1. That student also needs to be sorted in the same way that you sorted your seats. Otherwise, everything's going to fall out of order, right? Because your numbers in your array indicate your assigned seating. So we need to do a couple of things here. Let's first understand our hints, then we will start understanding what the question is asking of us, understand the return, and then build out our function. Okay? Can we greedily match each student to the seat, right? We saw here that student number 3, that seat number 3, right? And student number 2 is where the same, like, assignment, and they sort of, like, it doesn't fall in chronological order. So we have position 1, and then we have position 3, and then we have position 5, right? So, like, we don't know what position 2 is, what position, like, 4 is, because we go from position 2 to position 1 and position 4 to position 3, but we don't end up replacing, right, those like, empty slots. So can we greedily, like, assign things, and maybe, like, if we say that 2 and 4 don't exist, it's still in order if you go 1, 3, 5, 7, right? Like, even if you skip a seat, it's still the same order. And then, you know, the smallest position student will go to the smallest position chair, and then the next smallest position student will go to the next smallest position chair, and so on and so forth. Okay? So that is a big hint that tells us, you know, it might be best if we sort our arrays that are being sent in from smallest to largest, because that way you can keep your order properly. So, great. Now that we got that out of the way, hopefully this will make a little bit more sense if we can take a look at the parameters being passed through. Okay, so we are passed two arrays of numbers, right? In the arrays of numbers, in the arrays 1, of the arrays indicates assigned student seating, and the second array indicates their current seating. Okay, assignment. We need to arrange the students so that they satisfy the seats array arrangement. Okay, no two seats can be occupied at the same time. The arrays that are passed to us will only contain numbers, so we don't have to take into account, any special characters, alphabet letters, or like nested arrays or objects. Okay, and the numbers represented by the seats array indicates the seating arrangement of the students array. Okay, and that's hopefully that gives you an idea of what these two sentences mean. You are given an array of seats of length n, where seats I is the position of seats of the ith seat, and so on and so forth. Okay, now I want you to know something. Okay, we are going to return the total number of steps needed to satisfy the seating arrangement. Okay, so it's going to be probably a counter. Let's just say a counter. So if we're doing a counter, we're just counting upwards. But if you see here, these numbers are sometimes like the assigned seating. You're sometimes going from a lower seating arrangement to a higher seating arrangement, and sometimes they're going from a higher seating arrangement to a lower seating arrangement, and that indicates direction. But if you're not really caring about direction, the way you overcome that is with the absolute value, right? So if you're going from 2 to 1, or you're going from 1 to 2, it's still the difference is still 1. If you're going from 7 to 5 or from 5 to 7, the difference is still 2. But when you do 5 minus 7, the answer is -2. And when you do 7 minus 5, the answer is 2, right? We don't care about the sign here. We just want the absolute value, which is 2, okay? So keep that in mind, because we are going to be using that in our loop. So I'm going to just delete this line. And I'm going to start with, let's use a variable to count your steps. Okay, and we'll do let count, which is a number, equal to 0. Cool. Then we need to iterate. We need to sort our loops, our arrays. Sort the arrays in ascending order. So now that we have seats and students already being passed through as arguments into the function, we don't need to give them an assignment. We can just reassign them. So we'll say seats, and if you have used the sort function in JavaScript, you know that you need to pass 2 variables into the method. Okay, so we'll do seats dot sort, and you have your two values, A and B. Like A would be the one that you are comparing with the next number. So this would be the index that you are currently on, and the next index, right? And A minus B means that if A is smaller than B, sort it in ascending order. If we were to say B minus A, you'll take the larger number and you'll place it first. So this is in descending order. All right, so this is A minus B. We want it in ascending order. I'm going to do this and just change seats here to students, and this to students. Okay. And if you do this, you'll see console log seats students, and then same thing here, seats and students. And this is, I'm going to say sorted. Okay. We'll take a look here. And you'll see 3, 1, and 5, 2, 7, and 4, 1, 3, and 5, 2, 4, and 7. And this is in line with this third hint that the smallest positioned student, right, will go with, because this is our seating arrangement and these are our students, the smallest, when I is 0, right? So seats 0 tells you that you are dealing with the first student, and the first student's position is 1, so we'll go from 2 to 1, which tells us exactly like what we are doing here. And then when we are going from position 4 to 3, we're doing 4 to 3, right? And then 7 to 5, it's going to be 7 to 5. And all we really need to do to go from this this position to this position is just determine the number of steps, which ends up being the difference. Okay? I'm going to take out these console logs. And we need to do an iteration over our loop. And I'm going to use a for loop for this. So it's going to be a number, right? I is less than, it can be any array since they are both the same length. You can iterate over students or you can iterate over seats. I'm just going to use seats since it's a shorter variable, and then I++, plus for our iterator. Count plus equals the difference of the arrays of the numbers, right? But like I said, we don't care about the direction. So I'm going to take the absolute value of seats I minus students I. Okay? And we'll return count. So you'll see here in total, the answer will be 1 plus 2 plus 1 plus equal to 4, right? Let's maybe, is there anything here that would show clarity, that maybe might show clarity? We'll do this. Console log, and we'll just show count as it starts counting up, okay? And we'll return count. I believe this should give us, let me do this so that you can see the function and then see our answer, right? When I is 0, count is 1, because that is the difference between, well, I don't have the, let me just, I'll say seats and students. Right? You see here, when we are taking the difference, the absolute difference, right? For this example, it's 1 and 2, count is 1. We're adding to our counter to see how many steps it takes. Then we're going from 4 to 3, and we're adding 1 more, right? And then 7 to 5, we're adding 2 more, and that's how we end up with our count of 4. Let's see if we can find one where these numbers are not all bigger, right? Can they go in either direction? I guess they don't go in either direction, because, well, it's maybe because it is sorted. 3 and 5, 2 and 4, possibly. Okay. Yeah, well, I wonder if I take out math.abs, if this will give me still the proper answer in all of my test cases. And if it will pass because of the sort. Yeah, see, when we don't do the absolute value, count ends up having a negative number. I guess then it's just like a directional change. You can do students and seats, but for the sake of simplicity, I'm just going to keep math.abs in my solution, and that way I don't have to really care too much about the direction. But yeah, let's submit our solution here. Perfect. So there we go. It is finally accepted. As you can see here, I believe in terms of like the time complexity of this problem, since we are doing sorting twice, I think a sort is an n squared solution. Sort JavaScript. And I think it's because we did a bubble sort. We'll do time complexity. It's n log n. Okay, so we do n log n for these sorts twice, and then O of n for our iterator for our loop, and then another O of n for our operation and our counter. So yeah, you'll see these solutions can be improved on. Honestly, the sorts end up being pretty inefficient. You are more than likely to be able to present this solution, and as long as you are able to explain it to your interviewer, have a good time with the interview, and potentially get a job offer. But yeah, hopefully this has made sense to you, and you guys have seen a new way to solve this problem. If you learned something here today, please like the video and let me know in the comments below what you learned. If you like these type of videos, subscribe to the channel. I do these on a regular basis whenever I do a new LeetCode problem. Once again, my name is Jamil. Thank you so much for tuning in, and I'll see you next video.